Okay.
The documents.
Okay, this document.
Yes.
So, okay, you can start.
Good morning, students. Good morning. How are you? Yeah, it's mathematics. Efosa, you're welcome. Miriam Sulaiman, you're also welcome. Okay, you're welcome. So, yeah, good morning, Raimat. Good morning. Good morning. Thank you. You're welcome. Okay, so the topic today, Aziz, you're welcome to. Good morning. All right, so the topic today is simultaneous linear equation with quadratic equation. But today we are going to use graphical method. I'm going to make use of graph to solve quadratic equation together with linear equation. Of course, this will give us an approximate value, which is very close to the true value if we have used the elimination method or the substitution method. Okay. Now, the objective is we want to solve accurately only linear equation and one non-linear equation with the use of graph. Okay. I will have said during the last lesson I should come along with graph or to practice with graph, but notwithstanding, after today's lesson, you can still get your graph book and practice. Okay. Now, just a quick introduction before we begin properly. Now we have example Daytonia, which can be rearranged to make addition. Okay, in the task given below, you have about 3 words or anagrams. You have 3 anagrams. Okay, so if you rewrite them correctly, the first one give you quadratic. Okay, beautiful, Rakib, beautiful, radius, thank you. Then what about the third one? Adiza, beautiful, radius. Miriam, quadratic, radius, beautiful. That's brilliant of you. Okay, then the third one is interior, no, outer, no, but you tried anyway. You really tried. Intersection, Abiba, that's brilliant. Intersection, beautiful. Raima Saladin, okay, beautiful. Intersection, Miriam, yeah, beautiful. Thank you. All right, so move on to this topic proper that has to do with solving quadratic equation and linear equation with the use of graph. Okay, with the use of graph. David, what are you talking about? I don't understand. What are you saying? Okay, now I want you to all settle down and look at what we have today. Now, if you look at the example 1, remember we have discussed how to make use of elimination method to solve both quadratic and linear equation. Okay, and we have also made use of substitution method. So this is the third type of method we can also use to solve combination of quadratic equation as well as linear equation. Okay, now consider the example given. Consider the example given. Says find the approximate solution to the pair of equations y is equals to x squared plus x minus 2 and y equals 2x plus 3 by graphical means. Okay. Now, you realize that the first equation given to you is quadratic. Mama, can you change your name to your real name so we understand who I'm chatting with? Okay, change your name. Change it from that design name to your real name. Okay. Now, let's continue. The first equation is given as a quadratic equation since we have 2x. Okay, Mama Sam. You're welcome. You're welcome. So we just started, so you can continue with us now. Now, the first is given as, all right, it's okay with your chatting each other. Just listen to what you have. Let's continue so we can cover time. All right. Now, consider this. Now, for you to have it in a graph, you have to set up a table. The table will be for your quadratic equation as well as for the linear equation. Okay. Now, since you have that y is equal x squared plus x minus 2, also y is equal to 2x plus 3. So for every value of x, there will be a corresponding value for y. And that is what you want to do. Now, that is a quadratic equation. And the other is of this form. Now, you realize that for my x, I take a range of values spanning from negative value to the positive value. Okay. Are you all following? You have to move from negative value to the positive value because it's quadratic. And if you have seen a quadratic graph before, it's a curve. And for you to make it a perfect curve, you have to move from that negative value to the positive value. Okay, so that is why I have my value of x to range from -4 to +4. Okay, now for every value of x, there will be a corresponding value of y. This is the linear part of the equation, and we also have the same value. So you realize that my value of x is also value of y. The range of value of x is also range of value of y, so that I can have both curve or both graph on the same sheet. Okay. Now, all we need to do is to substitute the value of x so we can work out the value of y. Similarly, beautiful. Okay, let's continue. Now, for each value of x, now taking my x to be -4, and I substitute into y. Agoro, I want to concentrate. Okay, I want to concentrate. Take x to be -4, substitute into the value of that quadratic equation, you now get corresponding value for y. So just as you have it now, I will have it -4 squared, that will give us 16, then -4 minus 2. Okay, so when you have it this way, the corresponding value will now be 10. Okay, that is when my x is -4, I have y to be 10. When x is -4, I have y to be 10. I'll do that same for when x is -3. Okay, you substitute into the quadratic equation, you get the corresponding value for y. So when you do that, you get 9 minus 3 minus 2, 9 minus 3 minus 2, and that will give you 4. Okay, 9 minus 3 minus, and that will give you 4. We do the same for negative 2. When x is negative 2, remember, you create a table for quadratic equation, you create a table for linear equation, you bring in set of values for your x, okay? So for that value of x, you get a corresponding value for y. All right, so that's what we are doing. But first, for quadratic equation first. All right, so then for the third one, negative 2, we have in this way, substitute the equation. From there, we get the corresponding value for y. Yasmin Yusuf is simultaneous equation for linear and quadratic equation using graphical method. That's the topic. Okay. So we have that to be 0. When you substitute x to be negative 2. Now, x to be negative 1, we also have it to be negative 2. Okay. All right. So for x to be 0, we have y to be negative 2. For x to be 1, we have y to be 0. Okay. And also for x to be positive 2, you have your y to be 4. Okay. All right. So for x to be positive 3, you have y to be 10. You have y to be 10. Okay. And for x to be positive 4, remember I said you substitute the value of x into the quadratic equation, you now solve for your y, corresponding value of y. So when you do for y, you get 16. Rather, you get 18. All right, so that is the corresponding value for x and y. Now, what do? You plug this value into the graph. Okay, you plug this value into the graph. Okay, now when you look at the graph, you realize that we have 1 centimeter to represent 2 units as our scales. Okay, now when x is minus 4, y is 10. That would be our location. Okay, when x is minus 4, y is 10. So you trace on the graph sheet when x is minus 4. Okay, when x is minus 4, what is the corresponding value for your y, which is 10? So you asterisk it on the graph. Hope you can all see that. Okay, when x is minus 4, remember the vertical line is your y-axis, the horizontal line is your x-axis. So you have the negative x-axis and the positive x-axis, as well as the positive y-axis and the negative y-axis. So another point we want to place on the graph is when x is minus 3, you have y to be 4. So you search for it and you place it on the graph, okay, as you can see. Okay, then we also do for when x is minus 2, y is 0. So when you check that, when x is minus 2, y is 0, we'll plug it on the graph, as you can see. Okay, then we also do for when x is minus 1, y is minus 2. Okay, so we do that, we have it on the graph as well. When x is 0, y is minus 2. So you can see it, we have it on the graph too. Then when x is positive 1, y is 0. So once you do that, you have it on the graph as well. Okay. Now the next value, when x is 2, y is 4. When x is 2, y is 4. So we have it on the graph too. You plug it on it. Also, the next value, when x is 3, y is 10. When x is 3, y is 10. You have it on the graph too. Okay. And the last value is when x is 4, y is 18. Okay, so you plot that, you have it on the graph, as you can see. Now you realize that you have a curve. Okay, so that is the typical way to draw the quadratic equation, to always give you curve. So whenever you see a curve of this nature on the graph, you should know that that is a quadratic equation. Okay, now to draw it, it will be a curve. Can you see? We have it as a curve on the graph. Okay, now the next thing is to consider the table for the linear equation. Okay, now as you have done for the quadratic equation, we'll do same for the linear equation. Okay, okay, so we continue with this. Now we also substitute the value for x into the curve as well, into the linear equation given as y is equal to 2x plus 3. So when when x is equal to minus 4, what will be the corresponding value for your y? So when you do that, you get minus 8 plus 3. So that will give you minus 5, the first value. Okay. Now for the second value, Miriam, you said your question, simultaneous equation. So any curve in mass is a quadratic equation. Now look at the curve on the graph. Okay, look at that curve on the graph. Once you see curve of this nature, okay, you should know that it is a quadratic equation. You have a minimum value, which is the u point. So any curve of this nature is a quadratic equation. Okay, thank you. Now, corresponding value when x is minus 3, we have it to be minus 3. Okay, then the third one, when x is minus 2, we have it to be minus 1. When x is minus 2, we have it to be minus 1. Okay, now the fourth point, when x is minus 1, what is corresponding value for y? You substitute into the equation, linear equation, and you get 1. Okay, then when x is 0, you have it to be 3. Okay, you have it to be 3. Then when x is 1, that will be 2 plus 3 to give you 5. Remember, just substitute into the linear equation to get the corresponding value for the y, as we have done for the quadratic equation earlier. Okay, now when x is 2, the corresponding value gives 7 for y. Okay, now when x is 3, you have it to be 9. Then the last value, when x is 4, you have it to be 11. Okay, now just as we did earlier, we are going to plug these values for x and y into that same graph sheet we have. Okay, now doing that, we consider when x is minus 3, y is also minus 3. So doing that, we can get the value on the graph sheet. Okay, then the next value, when x is minus 2, y is minus 1. Alima, we are not concentrating. Okay, so when x is minus 2, y is minus 1. We can plug that on the graph sheet as you have it, as you can see right now. The next value is when x is minus 1, we have y to be 1. We plug it in, we have that 2. Okay, Then next value, when x is 0, y is 3. When x is 0, y is 3. So you can see as we plug it in. Okay. Then next value, when x is 1, y is 5. We plug it in. When x is 1, y is 5. Okay. They are both positive. The next value, when x is positive 2, y is positive 7. You trace it and you put your point, or you put your asterisk to show that you have located those points on the Cartesian graph. Then another point is when x is 3, 9, and y is 9. You search for it and you put it down. You can screenshot it on you. Okay, good. Okay, you get that. And then the last point, when x is 4, y is 11. Okay, we have that. Now you can see that it forms a line. It forms a line just to show you that that is a line graph. Okay, so the next thing is to join those points together, and we will see where we have the intersect. Can you see? That's the line. Okay, that is the line. Now, looking at it, we can realize that line cuts at a certain value. That equation of rather the graph of the quadratic equation at 2 points. So those 2 points will be the approximate root of the equation. You can see the point 1, okay? Point 1, and that's the point 2. So what you do is to trace it to the corresponding value for y and corresponding value for x at that point of intersect, okay? At the point of intersect, you trace it to get the corresponding value for x as well as for y, okay? So the approximate solution, this is the first one. Okay, you can see the first point, their intersect falls on the negative side of the equation. So we have the negative roughly 1.8 for x, okay, and minus 0.6 for y, okay. Then the second point for your x is about 2.8, and for y is about 8.6, okay. So these are the approximate solution for the given equations. So if you can also try it, you can make use of elimination method, substitution method to check for this approximate solution. Sunny, you said you don't understand. You'll be given 2 equations. One is quadratic equation, the other one is Alima, you too. Now listen again. Okay, the approximate, thank you. Now, on the point of intersect, okay, where 2 graphs passes through each other, when they cut each other, at that point, you will trace it to the value of x and the value of y to get the point of intersect. Okay, now the first point of intersect, okay. All right. Now let us consider this before I ask you to do the next one. Like I said, the point of intersect earlier, you trace it to y-axis and x-axis. Okay. Now the corresponding value that combine, when you combine those value, okay, when you search through the value, let me quickly take it back. Okay. The first intersect, okay, you trace it to the line of x, that is x-axis. What is the value? You write it down. So for x-axis, we have it to be minus 1.8. And that same intersect, you trace it to the y-axis, okay, which is the vertical axis. You have it to be minus 0.8. Then you go to the second intersect, okay. Second intersect, you trace it to the y-axis, which is about 8.6, okay. And also you trace it down on the x-axis to give you 2.8. Okay. Now consider the next example. I'll rush do this so that you're able to write down another. So you write down and you can do the rest. Okay. Now, same as you're giving earlier, you're giving quadratic equation as well as a linear equation. But the linear equation is given as y is equals to x. The quadratic equation is given as x squared plus 3x minus 2. Okay. Just as I said, you form a table of values for your x. Make sure you may start from minus 3 to positive 3. Okay. That is minus 3, minus 2, minus 1, 0, 1, 2, 3. We can start from that. But some instances, equation, I mean, the range of values should be given to you. Okay. All right, let me. Okay. Now, what we have done here is what we'll do in the next slide. Now, consider this slide. Consider this slide. You'll be given quadratic equation as well as linear equation. So you form a set of values for your x, or it may be given to you. It depends on the question. Now, so for each value of x, you get the corresponding value of y when you substitute the value of x into the equation. Okay. So once you do that, you get a corresponding value of y. And that is what you will plug onto the graph sheet to locate the corresponding point. And you will draw it out, the graph, the type of graph. It will display a type of graph it is. You do the same for the quadratic equation as well as the linear equation. Okay, now, so you now realize that there is a cut in between the linear equation and quadratic equation. So that point form the intersect. So that intersect spell out the solution for both equation. Okay, all you need to do is to trace it to the corresponding x-axis and y-axis. You write down what the value given, the values are. Also, another intersect, you trace it to the y-axis and the x-axis to get the value. Okay, so I will move on from this to the next slide. Okay, now the next slide, we are given this as well, just as what we have done. So we'll be a bit fast in this slide. Okay, now on this slide will be very fast. So we have a set of value for y-axis, quadratic equation. So like I said, your set of values for x, I'm starting with my -4 here, ending with 4. You can start from -3 and end with 3. Okay, so just be digressive about it. And as like I said, some instances and equation will be, range of values will be given for you, so you can make use of it. So that's for your y. For each value of x, we have corresponding for y. Okay. Now, just as we have done earlier, substitute y, x to be -4 into the equation. You have that to be 2, -2, -4. When x is -1, the corresponding value of y is -4. When x is when x is 0, corresponding value is -2. When x is 1, y is 2. When x is 2, y is 8. And when x is 3, y is 16. When x is 4, y is 26. Okay. And that is what we plug on the graph sheet. So just trace it. When x is minus 4, what is y? Okay. Y is 2. So we have that. When x is minus 3, y is minus 2. We have that too. When x is minus 2, y is minus 4. You have that. When x is minus 1, y is minus 4. When x is 0, y is minus 2. When x is 1, y is 2. Okay, so you can draw that because every other will be out of place. So we have this to be value or the graph for the quadratic equation. Now let us consider that of linear equation too. So remember that the linear is given as y equals to x. So for each value of x, you have a corresponding value of y, which is the same because y is equals to x. Okay, so we just repeat all that same value of x, and that is what we also draw on. We'll locate the close point on the graph. So minus 4 for x and y, minus 3 for x and y, minus 1, minus 1, minus 2 for both x and y, 0 and 0, okay, 1 on 1 for x and y, 2 on 2 for x and y, 3 and 3 for x and y, 4 and 4 for x and y. So from there you have this straight line graph cutting through. Again, you realize that the straight line graph cuts through the quadratic graph. So hence giving us two intersects. Okay, so those intersect, you now trace it to the y-axis as well as the x-axis to give you the corresponding results or roots. Okay, so since you have two intersects, so you trace both to x-axis as well as y-axis. Okay, and so that's the first intersect, and that's the second intersect. Okay, now, so for the first one, we have 0.7, 0.7. And second one, we have minus 2.7, minus 2.7. Like I said, you trace it to x and y, both intersect. Okay, now, have you snapped this on your screen? Okay, I didn't know, I'm listening. What's your question? Just type in. Type in, what do you want? Okay. Okay, so okay. All right. Miriam, now screenshot this. So I want you to write down the next one. Okay, so I believe you have this, you have as a screenshot already. Efosa, what's your question? Okay. Type in your question before we move on. All right, beautiful. Thank you. Is it I now understand or I don't understand? I can see I now understand. That's brilliant of you. Okay, Now, the next slide. Okay. Now, copy this down, or we can also do this together. So I'll give you, because of the time. Now, let's do this together. Okay. Just as we have, like I said, your range of value of x will be given, and if it's not given, you have to bring in your own. Okay. Just make sure that you have it spanning through negative value to the positive value, so you can have that full curve for the values. Okay. Now remember that whatever values you have used for the quadratic equation, whatever value of x used for quadratic equation, is same thing used for the linear equation. Okay. Now, so like I said, for value of x substitute into the value of the quadratic equation, you get corresponding value for y. So we are doing this, you have all these answers. Okay. Now you find the corresponding, you locate it on that graph sheet. Okay. Since we have done about two, that's why I'm a bit fast on this. Okay. That's why I'm a bit fast on this. So we have this type of curve. Can you see? Because it has to move from negative to positive. So you have that full curve. Okay. So you have that full curve. Then the next thing is for the y. The same thing. So when you plug those values into value of x into the equation, linear equation, you have the corresponding value for y, and you now locate those curves, those points on that same graph sheet, so that you can get the curve. You can get the intersect on the curve. Like I said, the intersect is the root of both equations. Okay, so locating the point, corresponding value for x and y for the linear equation. So you have this, and you have that line cutting through the graph, Now, so where it cuts the graph is your point of intersect. Okay, again, when both graphs, the curve and the line, where they join, when they meet, okay, where they cut is your point of intersect. So that point of intersect, you trace it to the x-axis as well as the y-axis, you write it down, and the second intersect, you do same, and you put it down. Okay. So doing that, I have this. Okay. All right. So I have this. So I want to screenshot this as well. Okay. Screenshot this. Okay. Screenshot this. I want to give you what to do, because I know most of you don't have your graph sheets, but once I give you what to do, you can quickly get a graph sheet and do a beautiful thing on it and just show it to me. Okay, I guess you all have this on your screen right now. Okay, so I want to move to the next slide so I can have time to interact with you. Okay, now don't worry about this. I want you to write down which one? Fatima, is it the next slide or this very one? Okay, all right. Okay, so Aziz, I'm on the slide you request, as well as Fatima. I'm on that slide. Okay. All right. What about Aziz? Are you done with it? Are you done with this slide? Okay, I give you about 30 seconds so we can move on. All right, thank you. Don't worry about this. I want to give you assignments because we have done about 3 graphs now. Because I don't know, most of you don't have graph sheet now, so that's why I have to move. Okay. You can screenshot this if you want, but I want to give you assignments. Okay. So I'll give about 30 seconds for this. I give 30 seconds for this. Okay. So once this is done, I'll give you the assignment proper. I have a beautiful, Sonny, you have graph. Beautiful. So you can quickly do the practice. Okay. So are you done with this slide? I want to move it to the next slide. Are you all done with this slide? Miriam, you can get graph. You can get graph in your area, whichever. You can get graph, okay? Now, use this as your assignment. Now, have this as your assignment and send to me, okay? Okay, copy down the assignment and send to me. Anybody with a question? Anybody with a question? You can ask me verbally, orally, signify by just raise hand. Okay. Abiba, let me see where you are. Yeah. Hold on. Hold on. Let me see where you are. Okay, I've seen Zainab. Zainab, your question, I can hear you now. What?
So is it only the answer we should send?
You don't?
Is it only the answer we should send?
I've told you the answer.
Like, is it the answer we should send for the assignment?
Okay. Do the graph. Let me just see how it look like. You will screenshot it now and you send to me. Most of you have been doing that. Click on the graph sheet and send to me. Okay.
So we should screenshot it.
Yeah, screenshot it. Yeah. Thank you. Fatima, I can hear you now, Fatima.
Sir,
Yes.
can we just do the assignments in table form instead of doing it in graph form?
If you don't have, fine. If you cannot, I repeat, if you cannot, it's so difficult for you to get a graph sheet, then you can do it in table form. But I really need the, well, I mean, the point of intersection, both point of intersection. Okay.
Okay, sir.
You're welcome. Okay. Any other person? Zainab, is still raising? Daniel.
Sir,
Okay.
so I'm going to send the graph to you.
Once you have it, once you have done the graph sheet, just use your picture, I mean your camera on your phone, screenshot it,
I'll send it to you.
and send it, just attach it. That's all.
Okay.
All right. Okay, Latif. Okay.
What is on the board? Is it the assignment?
Yes, the assignment. So give it a try. Let me see what you can do with it. Okay.
Okay, sir.
All right. Okay, so God's willing, I will see you on during the next lesson, and that'll be on Saturday. God be with us all. Okay. Thank you all. Okay, I end the meeting. You end it for all.
It's out for
For all.